When Nazi Germany surrendered on May 8, 1945, the Allied forces found themselves in possession of the most formidable arsenal ever assembled by a single nation. From the forests of Bavaria to the concrete bunkers along the Atlantic Wall, from the shipyards of Hamburg to the secret weapons facilities hidden deep in mountain caves, German military hardware represented years of innovation, desperation, and industrial might. Thousands of tanks sat abandoned in fields across Europe, their Panzer crews having fled or surrendered. Hundreds of submarines lurked in harbours from Norway to France, their wolf-pack tactics finally silenced. Fighter aircraft lined airfields, some so advanced they seemed plucked from science fiction. Artillery pieces that had bombarded entire cities stood silent, and beneath it all lay secrets, revolutionary technologies that would reshape the post-war world in ways few could have imagined. What became of this massive stockpile of weaponry? How did the victorious Allies divide, study, destroy, or repurpose the instruments of the Third Reich's war machine? The answer reveals not just the fate of metal and machinery, but the dawn of the Cold War, the birth of the space age, and the complex moral questions that followed total victory. In this video, we will find out. So, without further ado, let's start with the first category on our list. The story of Germany's captured submarines represents one of the most dramatic episodes in the disposal of Nazi weapons. When Admiral Karl Dönitz, Hitler's designated successor, issued the order for all U-boats to surface and surrender on May 8, 1945, more than 150 submarines were still operational at sea. These vessels, which had terrorized Allied shipping lanes for nearly 6 years, now became prizes of war, technological treasures, and ultimately evidence of a bygone era of warfare. The surrender process was carefully orchestrated across multiple harbours in Britain, Norway, and occupied Germany. At Loch Erebor in the Scottish Highlands, nearly 40 U-boats gathered in what witnesses described as a ghostly armada, their conning towers breaking the grey waters in silent defeat. Royal Navy boarding parties methodically seized codebooks, navigation charts, and operational documents, while armed guards ensured the German crews remained compliant. The submarines themselves varied wildly in condition. Some had been at sea for months, their hulls crusted with barnacles, their diesel engines barely functional. Others were nearly pristine, having just departed from Norwegian bases when the surrender order came. Among the captured fleet were vessels that represented the cutting edge of underwater warfare technology. The Type 35 boats, with their streamlined hulls and revolutionary battery systems, could remain submerged far longer than any previous submarine design. The Type 44's coastal boats were smaller but equally advanced, designed for shallow water operations that traditional submarines could never attempt. Allied intelligence officers immediately recognized the value of these technological marvels. British, American, and Soviet representatives converged on the captured harbours, each nation eager to claim the most advanced examples for study. The Tripartite Naval Commission was hastily formed to manage the distribution, with each major Allied power receiving 10 submarines for detailed examination. The United States took possession of several Type 34 boats, towing them across the Atlantic to naval facilities where engineers could dismantle and analyse every system. The Royal Navy claimed its share, renaming captured U-boats with HMS designations and putting them through exhaustive sea trials around the British Isles. The Soviet Union, excluded from much of the Western naval technology sharing during the war, demanded and received its allocation, transporting the submarines to Baltic ports where they would influence Soviet submarine design for decades to come. But what of the remaining submarines, those not selected for study or preservation? Their fate was sealed by Operation Deadlight, one of the most methodical destruction programs in naval history. By autumn 1945, British harbours were clogged with over 100 captured U-boats that served no intelligence purpose and posed a significant maintenance burden. The Royal Navy devised a solution that was both practical and symbolic. Between November 1945 and February 1946, these submarines would be towed into the deep Atlantic and deliberately sunk, ensuring they could never again threaten Allied shipping. The operation was divided into 3 dumping zones designated XX, YY, and ZZ, located roughly 100 to 120 nautical miles northwest of Ireland, where the ocean floor plunged to depths exceeding 1,000 feet. The logistics proved far more challenging than anticipated. Many of the condemned U-boats were in deplorable condition after months or years of continuous service. Their ballast tanks leaked, their engines were seized, and their hulls had been weakened by depth charge attacks and corrosion. Winter storms in the North Atlantic made towing these unstable hulks genuinely dangerous work. Royal Navy tugs would connect heavy cables to the submarines and begin the slow journey westward, but frequently the tow lines snapped or the submarines simply foundered in rough seas before reaching the designated scuttling zones. Of the 116 U-boats earmarked for destruction, 56 sank during transit. Their wrecks scattered across the seabed between the Irish coast and the dumping grounds. The Royal Navy recorded each loss but made no effort at recovery, since destruction was the entire purpose of the operation. For the submarines that did reach the designated zones, the end came through various means. Some were deliberately scuttled by opening their sea valves and allowing the Atlantic to flood their compartments. Others were used for target practice, with Royal Navy destroyers and frigates firing salvos of shells into their hulls until they slipped beneath the waves. A few were dispatched with aerial rockets or explosive charges placed by demolition teams who boarded the doomed vessels for a final time. Among the submarines destroyed was U-2336, notable for being the last U-boat to sink Allied merchant ships during the war. It had surrendered at Halley in Northern Ireland in June 1945, and was towed to the scuttling grounds in January 1946, where naval gunfire sent it to the bottom. U-295 met a similar fate on December 17, 1945, after being towed from Loch Ryan in Scotland. The U-2511, one of the few fully operational Type 30 submarines, and arguably the most advanced submarine in the world at war's end, was kept afloat longer for additional testing before being scuttled on February 7, 1946. Marking the official conclusion of Operation Deadlight. For decades, the Deadlight wrecks lay. Forgotten in the cold Atlantic depths, their locations marked on classified charts but otherwise ignored by maritime authorities and the public. Then, in the early 2000s, maritime archaeologist Innes McCartney launched a series of expeditions to relocate and document these underwater grave sites. Using side-scan sonar and remotely operated vehicles, McCartney's team systematically surveyed the dumping zones between 2001 and 2003. What they discovered was remarkable. At least 14 intact U-boat hulls were identified, many resting upright on the seabed as if they had simply settled there peacefully. The submarine's decks were still armed with anti-aircraft guns, though now encrusted with marine growth. Hatches remained sealed, preserving the interior spaces in eerie darkness. The cold temperatures and minimal currents at depth had prevented rapid deterioration, creating a time capsule of Germany's underwater warfare capabilities. McCartney's findings revealed how hastily some of the scuttlings had been carried out, with submarines sinking before explosive charges could be properly placed or sea valves fully opened. The archaeological record told a story of practical necessity rather than ceremonial destruction. The Royal Navy's priority had been simply to get these potentially dangerous vessels off its hands, not to create a dignified end for technological achievements. Operation Deadlight served its immediate purpose of eliminating a maintenance burden and preventing any possibility of the submarines falling into unauthorized hands. But it also represented a broader Allied policy toward German weapons. Those that offered no intelligence value or could not be effectively controlled were better destroyed than preserved. This philosophy would be applied to numerous other categories of German military hardware in the months and years following the war. Yet even destruction had its limits. The submarines allocated to the United States, Britain, and the Soviet Union. For study would have profound impacts on post-war naval development, influences that extended far beyond the immediate technical knowledge gained from dismantling a few captured vessels. Moving to surface naval vessels, the fate of Germany's Kriegsmarine extended well beyond its submarine fleet. When the war ended, the German Navy's surface forces consisted of a battered but still substantial collection of warships, from pocket battleships to destroyers, from torpedo boats to minesweepers. Unlike the submarines, which surrendered at sea or in captured ports, many of these surface vessels were trapped in German harbours by Allied air superiority and had been subjected to years of bombing. The heavy cruiser Prinz Eugen, famous for accompanying the Bismarck on its fatal sortie in 1941 and surviving as one of the few major German warships to remain operational throughout the war, became a particularly valuable prize. The United States claimed the Prinz Eugen and towed it across the Atlantic to Boston, where naval architects studied its advanced fire control systems and armor layout. After extensive testing and analysis, the Americans included the cruiser in Operation Crossroads, the atomic bomb tests conducted at Bikini Atoll in July 1946. The Prinz Eugen survived both the airburst and underwater atomic explosions, but was contaminated with radiation. It was towed to Kwajalein Atoll, where it eventually capsized and sank in December 1946. Its radioactive hulk remaining visible above the waterline as a twisted monument to both German naval engineering and the dawn of the atomic age. The battleship Tirpitz, sister ship to the Bismarck, never fell into Allied hands because it had been destroyed by British bombers in November 1944 while anchored in a Norwegian fjord. However, its massive wreck became a salvage operation that lasted for years, with Norwegian companies cutting apart the hull to recover valuable steel and non-ferrous metals. The process took until the 1950s to complete, with some sections of the armour belt proving so thick and resilient that specialised cutting equipment had to be developed. Similarly, the incomplete aircraft carrier Graf Zeppelin, Germany's only attempt at building a fleet carrier, was captured by Soviet forces in the Baltic. The Soviets experimented with the carrier, using it for target practice and weapons testing before finally sinking it in 1947. The pocket battleship Admiral Scheer, which had raided Allied shipping routes in the Atlantic and Indian Oceans earlier in the war, was destroyed by British bombers in Kiel Harbour in April 1945 and later razed and scrapped. The Admiral Graf Spee had already been scuttled by its crew off Montevideo, Uruguay, in December 1939, and its wreck remains partially visible in the River Plate to this day. Smaller surface combatants faced a variety of fates depending on their condition and the priorities of the occupying forces. The Soviet Union, desperate to rebuild its own devastated navy, claimed numerous German destroyers, torpedo boats, and auxiliary vessels as reparations. These ships were integrated into the Soviet Navy, often serving for another decade or more with Russian crews before being scrapped. Britain similarly took possession of several German destroyers and minesweepers, some of which were commissioned into the Royal Navy for a brief period before being sold to other nations or broken up. One German destroyer, the Z-38, was transferred to Britain and recommissioned as HMS Nonsuch, serving as a training vessel until 1949. France received a number of torpedo boats and escort vessels, incorporating them into the Marine Nationale to help rebuild French naval strength after years of occupation and Vichy control. The minesweepers presented a unique category because they were desperately needed for clearing the extensive minefields that German forces had laid around European waters. Rather than destroying these vessels, the Allies put many of them back to work under Allied supervision with mixed German and Allied crews. This practical arrangement lasted well into the late 1940s as the painstaking process of sweeping millions of mines from shipping lanes continued. German sailors, many of them prisoners of war, found themselves performing the same dangerous work they had done during the conflict, but now under the flags of their former enemies. The irony was not lost on these men, who cleared German mines that might have sunk their own former comrades, but the work was necessary and represented one of the few ways German naval personnel could contribute to the reconstruction of European maritime commerce. German naval auxiliary vessels, including tenders, supply ships, repair vessels, and training ships, were distributed among the Allies based on immediate needs. The Soviet Union, which had lost enormous amounts of merchant and naval tonnage during the war, took the lion's share of these support vessels. Many were in poor condition after years of service and Allied bombing, but Soviet shipyards were well practiced in making do with damaged or outdated equipment. The British and Americans were more selective, taking only those vessels that offered specific capabilities or could be converted for peacetime use. A number of German merchant ships that had been pressed into military service were returned to civilian operation, though under Allied control and often with new names and registry. The question of what constituted a naval vessel versus a civilian ship became legally contentious, with owners and operators sometimes contesting Allied seizures, but such protests rarely succeeded, given the total nature of Germany's defeat and occupation. The fate of Germany's tank forces reveals another dimension of Allied weapons disposal policies. The Panzer divisions that had revolutionized armored warfare and struck terror across Europe in the early war years ended 1945 as scattered remnants there. Once formidable machines abandoned in fields, broken down on roadsides, or captured in various states of repair. The Allies found themselves in possession of thousands of German tanks, ranging from obsolete Panzer IIs and IIIs to the fearsome Tigers and Panthers that had dominated the late war battlefield. The distribution and disposal of this armoured horde reflected both military interest and practical constraints. Unlike submarines or aircraft, tanks were relatively simple to understand technologically, and by 1945, all major Allied powers had developed their own effective tank designs. The primary value of German tanks lay not in revolutionary engineering secrets, but in studying their manufacturing techniques, armour metallurgy, and operational doctrine. The British collected numerous examples of German armour for testing and evaluation at their armoured fighting vehicle research facilities. Particular interest focused on the Panther medium tank, which many military historians and contemporaries considered the best all-around tank design of the war. British engineers subjected captured Panthers to exhaustive trials, testing their automotive reliability, examining their sloped armour schemes, and firing upon them with various Allied anti-tank weapons to understand their protective capabilities. The results were mixed. While the Panther's 75 Impala gun and thick frontal armour impressed British evaluators, the tank's mechanical unreliability and expensive production methods were noted as significant weaknesses. British designers drew lessons from the Panther's layout and armour scheme when developing post-war tanks like the Centurion, though they avoided adopting German engineering wholesale. The Tiger and Tiger sector heavy tanks similarly underwent detailed analysis, with British and American ordnance experts particularly interested in understanding how German industry had managed to produce such massive, complex vehicles, even as Allied bombing devastated German factories and transportation networks. The Americans brought several Tiger tanks to the Aberdeen Proving Ground in Maryland, where they joined a growing collection of captured enemy equipment. Engineers dismantled the Tigers piece by piece, cataloguing every component and testing various assemblies to failure. The findings confirmed what Allied intelligence had suspected. The Tigers were magnificently powerful, but absurdly over-engineered, requiring far too many man-hours to produce and too much maintenance to keep operational. American tank design philosophy, which emphasized reliability, ease of production, and volume over individual vehicle superiority, was validated by these studies. The Soviet Union acquired its own collection of German tanks, though Soviet interest was more focused on understanding how to defeat German armour in potential future conflicts, rather than adopting German design features. Soviet designers who had already developed the excellent T-34 medium tank and were working on the even more capable T-54, saw little to gain from German engineering approaches. Most captured German tanks that were not selected for technical evaluation faced a grimmer fate. Across occupied Germany and former battlefields throughout Europe, thousands of disabled or abandoned Panzers were collected and scrapped for their metal content. The urgent need for steel and other materials in rebuilding war-torn Europe meant that sentiment or historical preservation took a distant back seat to practical recycling. Tank hulls were cut up with torches and fed into blast furnaces, their armour plate melted down and repurposed for civilian reconstruction. By 1950, the vast majority of Germany's wartime tank production had been reduced to raw materials, with only a relative handful preserved in museums or kept for long-term study. Some tanks were used as targets on gunnery ranges where new anti-tank weapons could be tested against real armour, rather than mock-ups. This practice continued into the 1950s as NATO forces refined their tactics and equipment for potential conflict with the Soviet Union, ironically using captured German tanks as stand-ins for Soviet armour in many exercises. A peculiar category of tank disposal involved vehicles that were still mechanically functional and potentially useful for occupation duties or civil reconstruction. Some Panthers and Panzer IVs were pressed into service by Allied military governments in Germany, used for clearing rubble, removing demolished buildings, or even providing security at critical infrastructure sites during the chaotic, immediate post-war period. These tanks were carefully monitored and restricted in their deployment, with ammunition strictly controlled and German crews, where used, kept under close supervision. As order was gradually restored and civilian equipment became available, these operational German tanks were retired and scrapped, though a few lingered in service well into 1946. One unusual destination for captured German armour was Czechoslovakia, which had been a major producer of German tanks and assault guns during the occupation. After liberation, Czechoslovak authorities took possession of numerous Panzer IV and Hetzer tank destroyers that remained in Czech factories or had been abandoned by retreating German forces. These vehicles were repaired and incorporated into the new Czechoslovak army, serving alongside Soviet-supplied equipment. Some even saw combat in the 1948 Arab-Israeli War after Czechoslovakia sold them to Israeli forces, creating the surreal situation of German-designed tanks fighting in the Middle East 3 years after the Third Reich's collapse. The story of Germany's captured aircraft represents perhaps the most technologically significant category of seized weaponry. When Allied forces occupied German territory in the spring of 1945, they discovered airfields packed with aircraft representing the most advanced aeronautical engineering in the world. The Messerschmitt Me 262, the world's first operational jet fighter, had entered service in limited numbers during 1944 and demonstrated performance capabilities that Allied propeller-driven fighters simply could not match. The Arado R-234, the world's first operational jet bomber, had conducted reconnaissance missions over Britain with virtual impunity. Experimental aircraft like the rocket-powered Me-163 Comet and the bizarre asymmetrical Blohmen-Voss BV-141 reconnaissance plane revealed the extent of German willingness to pursue radical designs. The Allied scramble to secure these aircraft and their designers would trigger one of the most consequential technology transfers in aviation history, ultimately contributing to the jet age and the space race. American forces launched Operation Lusty, short for Luftwaffe Secret Technology, in early 1945, even before the war ended. Intelligence teams accompanied advancing troops specifically to locate and secure German aircraft and aviation facilities. The operation's scope was extraordinary, with American personnel seizing hundreds of aircraft, thousands of technical documents, and interrogating hundreds of German engineers and test pilots. The crown jewels of this haul were the Me-260 jets, several of which were carefully disassembled, crated, and shipped to Wright Field in Ohio for exhaustive analysis. American engineers flew captured Me-262s extensively, testing their Jumo 004 turbojet engines and evaluating their combat capabilities against American designs. The insights gained accelerated American jet fighter development, though American engineers noted significant flaws in the German jets, particularly their engines' poor reliability and short operational life. The Me-262's Jumo engines required complete overhaul after just 10 hours of operation, a maintenance burden that would have been unsustainable in sustained combat operations. British forces conducted their own systematic collection of German aircraft designated Operation Surgeon. The British were particularly interested in German jet and rocket technology, which complemented their own early jet development work. The Royal Air Force had already fielded the Gloucester Meteor, Britain's first operational jet fighter, but German jets offered alternative design approaches and valuable lessons. British technical intelligence teams secured numerous Arado R-203 jet bombers, Heinkel, her 162 Volksjäger jet fighters, and several examples of the Me-163 rocket interceptor. These aircraft were transported to the Royal Aircraft Establishment at Farnborough and other British facilities where they underwent detailed examination. British pilots flew captured Me-262s and R-234s in comparative trials against British jets and late-war piston fighters, documenting performance data that would inform British aviation policy for years. The Me-163 Comet, with its volatile rocket fuel and dangerous handling characteristics, fascinated and horrified British engineers in equal measure. While the Comet's stunning rate of climb and speed impressed evaluators, its tendency to explode on landing and its corrosive, toxic fuel system demonstrated the desperate measures Germany had taken in the war's final years. The Soviet Union, often overlooked in accounts of captured German aviation technology, was equally aggressive in securing German aircraft and expertise. Soviet forces swept through eastern Germany, occupying factories and research facilities that had produced some of Germany's most advanced designs. The Soviets were particularly interested in swept-wing research, an aerodynamic innovation that the Germans had pioneered and that would prove crucial to high-speed jet performance. Soviet engineers seized complete aircraft manufacturing equipment, technical drawings, and even compelled German engineers to continue working under Soviet supervision. Many of these engineers were eventually transported to the Soviet Union, where they worked on Soviet aviation projects for years before being allowed to return to Germany. The influence of German aviation technology on Soviet post-war aircraft development is evident in designs like the MiG-15 jet fighter, which bore clear resemblance to German swept-wing research, though Soviet designers incorporated their own innovations and improvements. France, despite being on the winning side, had seen its aviation industry devastated by occupation and received limited access to the most advanced German aircraft. French forces did manage to secure several examples of German aircraft from their occupation zone in Germany, and French engineers studied these carefully to help rebuild France's shattered aviation sector. The French industry, which had been among the world's leaders before the war, had fallen far behind during 4 years of occupation and Allied bombing. German technology offered a shortcut to catching up, though France would ultimately develop its own. Indigenous jet designs rather than simply copying German work. Beyond the jets and rocket planes, thousands of conventional German aircraft were captured intact or in repairable condition. Messerschmitt Bf-109 and Focke-Wulf FW-190 fighters, Junkers Ju-87, Stuka dive bombers, Junkers Ju-88 multi-role aircraft, Heinkel, He-100FM bombers and countless other types were found on airfields across Germany and occupied Europe. The Allies had little practical use for these obsolescent piston-engine aircraft, which Allied designs had generally surpassed by 1945. Some were evaluated briefly, others were used for pilot familiarization training, so Allied airmen could understand the capabilities of aircraft they had fought against, but the vast majority were simply destroyed. At some airfields, Allied forces used bulldozers to push rows of German aircraft into piles and set them ablaze, creating massive bonfires that consumed decades of German aviation development. Photographs from 1945 show surreal scenes of hundreds of aircraft, many appearing pristine, stacked and burning as occupation forces cleared airfields for Allied use or simply eliminated potential hazards. A particularly valuable subset of captured German aircraft were the experimental and prototype designs that revealed the direction of German aviation research. The Horten Ho 2-29, a jet-powered flying wing design that anticipated stealth aircraft concepts by decades, was captured incomplete in a factory and later transported to the United States, where it remains in storage at the Smithsonian Institution to this day. The Dornier Du 335 File, a unique push-pull twin-engine fighter with exceptional speed, was tested extensively by American and British pilots who marveled at its performance but noted its complexity and difficult handling. The Backenbach 349 Natter, a vertical-launch rocket interceptor designed for single-use attacks on Allied bomber formations, represented German desperation more than practical engineering, but it still fascinated Allied intelligence as an example of unconventional thinking. These prototype aircraft, many of which existed in only 1 or 2 examples, were carefully preserved for study, with some eventually finding their way into museums where they continue to demonstrate the breadth of German wartime aviation research. The human expertise behind German aviation proved as valuable as the hardware itself. Through programs like Operation Paperclip, the United States recruited German scientists, engineers, and technicians to work on American aerospace projects. These German experts brought not just theoretical knowledge, but practical experience in pushing the boundaries of flight technology. Many would go on to contribute to American missile development, space exploration, and advanced aircraft design. Their wartime work for the Third Reich overlooked or minimized in the interest of Cold War technological competition. The moral complexity of employing former Nazi scientists troubled some Allied officials, but the perceived threat from the Soviet Union and the value of German expertise generally outweighed such concerns. British and Soviet authorities conducted similar recruitment efforts, though the British program was smaller and the Soviet approach often involved less voluntary arrangements. What happened to the German aircraft industry's infrastructure reveals yet another dimension of Allied weapons policy. Factories that had produced thousands of aircraft were systematically dismantled under Allied occupation. Specialized machine tools were seized as reparations or destroyed to prevent Germany from rebuilding its military aviation capability. Wind tunnels, test facilities, and research laboratories were thoroughly documented and often disassembled, with valuable equipment shipped to Allied nations. The intention was not merely to seize German technology, but to ensure Germany could never again develop an independent military aviation sector. This policy would be maintained throughout the occupation period, with restrictions on German aviation continuing into the 1950s, when West Germany was rearmed as part of NATO and permitted to rebuild limited military forces under strict Allied supervision. German artillery pieces and heavy weapons faced a similar fate to tanks, though with some notable variations based on their utility and technological sophistication. When the war ended, the Allies discovered enormous stockpiles of German artillery, ranging from the famous 88 mm dual-purpose guns that had terrorized Allied armor to massive railway guns like the 800 mm Schwerer Gustav that had bombarded Sevastopol. The sheer quantity of German artillery was staggering, representing years of production across hundreds of factories and countless modifications and variants. Every Wehrmacht and Waffen-SS division had been equipped with artillery, and the remnants of these units left behind thousands of guns in various states of repair. The famous 80 mm gun, which had earned a fearsome reputation as both an anti-aircraft weapon and an anti-tank gun, attracted particular Allied interest. American and British ordnance experts examined numerous examples, documenting their versatile design and impressive performance characteristics. However, by 1945, both Allied powers had developed their own effective anti-aircraft and anti-tank weapons, reducing the urgency of adopting German gun designs. The Soviets, who had suffered tremendous casualties from German 80 mm fire, captured hundreds of these weapons and incorporated some into Soviet artillery units while using others for training and target practice. The truly massive German artillery pieces, the railway guns, and super-heavy siege weapons posed unique disposal challenges. The Schwerer Gustav, which weighed nearly 1,150 tons and required a crew of over 500 men to operate, was found partially dismantled by retreating German forces who had tried to prevent its capture. American troops discovered sections of this enormous weapon, which had fired 7-ton shells scattered near a rail line in Bavaria. The Gustav and its sister gun Dora were scrapped where they lay, their massive steel components cut apart with torches and sent to foundries. These weapons had been technological marvels, but also practical absurdities, so enormous and unwieldy that they could barely be used tactically. Their capture and destruction symbolized the end of an era of heavy artillery that had begun in World War I and reached its illogical extreme under Nazi gigantism. Other German railway guns, smaller but still massive weapons like the 200 mm K5 and the 210 Finnamin 12, were dispersed among Allied powers for study. The United States transported several K5 guns to Aberdeen Proving Ground, where they were extensively tested. British forces examined similar weapons, documenting their range and accuracy while noting the impracticality of such specialized equipment in modern mobile warfare. Standard German field artillery, the 102 mm and 150 mm howitzers that had formed the backbone of Wehrmacht fire support, were distributed based on need and convenience. The Soviet Union claimed vast quantities of these weapons as reparations, integrating them into Soviet artillery parks where they supplemented Soviet-designed guns. Nations like Poland, Yugoslavia, and Czechoslovakia, which were rebuilding their military forces in the immediate post-war period, received or took possession of German artillery that had been left in their territories. Some of these guns remained in service well into the 1950s and even 1960s, particularly in smaller armies that could not afford to completely re-equip with new weapons. France incorporated captured German artillery into its armed forces, using these weapons during colonial conflicts in Indochina and Algeria, before finally retiring them in favor of American-supplied equipment. The practical attitude toward German artillery reflected its nature as mature, well-understood technology. Unlike jets or submarines, these were conventional weapons that offered no revolutionary secrets, merely solid engineering that could be useful to forces needing to rebuild quickly and cheaply. German anti-aircraft weapons beyond the 80 mm included numerous lighter caliber guns and the sophisticated radar-directed systems that had defended German cities from Allied bombers. The 20 mm, 37 mm, and various configurations of multi-barrel light anti-aircraft guns were captured in huge numbers. These weapons had little value to the Allies, who had their own effective designs, and most were simply destroyed or scrapped. The radar and fire control systems, however, attracted intense interest. German engineers had developed sophisticated radar sets for directing anti-aircraft fire, and while Allied radar technology was generally superior, German approaches offered valuable comparative data. British and American technical intelligence teams systematically dismantled German radar installations, photographed and catalogued the components, and shipped selected examples back to Allied research facilities. The Soviet Union, whose radar technology lagged behind the Western Allies, was particularly aggressive in seizing German radar equipment and recruiting German radar specialists to work on Soviet projects. The category of small arms and infantry weapons reveals a different pattern in Allied weapons disposal. Germany had produced millions of rifles, machine guns, pistols, and other infantry weapons during the war, and vast quantities of these remained in 1945. The standard German infantry rifle, the Karabiner 98K bolt action rifle, was a refined and reliable weapon based on designs dating back to World War I. Millions of these rifles were in Allied hands by mid-1945, and their disposal reflected practical considerations rather than technological interest. The Western Allies had no need for German rifles as their own. Designs were entirely adequate, but other nations eagerly sought these weapons to equip their military and police forces. Yugoslavia acquired hundreds of thousands of German rifles and machine guns, using them to arm its partisan forces as they transitioned into a regular army. Poland, Czechoslovakia, and other Eastern European nations similarly absorbed large quantities of German small arms, with Soviet approval and often Soviet direction, as Stalin consolidated control over Eastern Europe. The German MG-34 and MG-42 machine guns represented the pinnacle of infantry firepower design and attracted particular attention. The MG-42, introduced in 1942, was arguably the finest general-purpose machine gun of the war, featuring a blistering rate of fire exceeding 1,200 rounds per minute and remarkable reliability under harsh conditions. American infantrymen had learned to respect and fear the distinctive sound of the MG-42, which they called Hitler's buzzsaw. After the war, American and British ordnance experts carefully studied captured MG-42s, documenting their operating mechanisms and manufacturing techniques. The gun's stamped steel construction and simplified design represented advances in production engineering that influenced post-war weapons development. The MG-42's design was so successful that it would be adopted by the West German military in the 1950s, when Germany was permitted to rearm, modified and redesignated as the MG-3, a weapon that remains in service today in various nations around the world, a testament to the quality of its original design. German submachine guns, particularly the MP-40, faced mixed fates. The MP-40 had equipped German paratroopers, tank crews and other specialized units throughout the war, and was an effective close-quarters weapon. Allied forces captured enormous quantities of MP-40s, and some Allied soldiers unofficially acquired them as personal weapons during the occupation, though regulations generally prohibited this practice. Most captured MP-40s were destroyed or given to Allied client states. Some found their way into the hands of various irregular forces, resistance groups, and even criminal organizations in the chaotic post-war years, adding to the flood of military weapons that would plague European law enforcement for decades. The MP-40's distinctive appearance made it an iconic weapon of World War II, but its practical value to post-war armies was limited as submachine gun design continued to evolve rapidly. German pistols, particularly the Walther P-38 and the Luger P-08, became prized war souvenirs among Allied soldiers. These were high-quality sidearms, well-made and effective, and many Allied servicemen acquired them through official surrender procedures or less official means. American and British occupation regulations attempted to control the taking of war trophies. requiring that captured weapons be registered and properly documented, but enforcement was inconsistent, and thousands of German pistols were brought home by Allied veterans. Those that were not taken as souvenirs were generally destroyed or issued to Allied-controlled German police forces in the occupation zones. The symbolic value of these weapons as trophies perhaps exceeded their practical military value, but they represented tangible proof of victory and became cherished keepsakes for veterans and their families. The fate of Germany's V-weapons program, the vengeance weapons that Hitler had hoped would turn the tide of war, represents one of the most consequential technology transfers of the post-war era. The V-1 flying bomb, essentially an early cruise missile, and the V-2 ballistic missile represented revolutionary developments in guided weapons technology. When Allied forces captured the V-weapon production facilities and testing sites, they found not just hardware but also extensive documentation and, crucially, the scientists and engineers who had developed these weapons. The V-2 rocket, in particular, designed under the direction of Wernher von Braun at the Peenemünde facility on the Baltic coast, was the world's first long-range ballistic missile and the technological ancestor of both Cold War nuclear missiles and space launch vehicles. The scramble to secure V-2 technology became one of the opening moves of the Cold War, with American and Soviet forces racing to capture as many rockets, components, and personnel as possible. American forces, acting on intelligence reports, moved swiftly to seize the underground V-2 production facility at Mittelwerk in the Harz Mountains before Soviet forces could arrive. In an operation of remarkable speed and organization, American troops located hundreds of V-2 components and shipped them by rail to the port of Antwerp, where they were loaded onto Liberty ships bound for the United States. This haul included enough parts to assemble approximately 100 complete V-2 rockets, an unprecedented windfall of advanced military technology. Simultaneously, American intelligence officers tracked down Wernher von Braun and his key associates, convincing them to surrender to American rather than Soviet forces. Von Braun and over 100 German rocket scientists were subsequently brought to the United States under Operation Paperclip, where they would become the core of America's nascent missile and space programs. The moral questions surrounding the recruitment of von Braun and his team, many of whom had been Nazi party members and whose rockets had been built by slave labor at Mittelwerk, were set aside in the face of Cold War imperatives. The Soviet Union, denied access to the main V-2 stockpiles by rapid American action, nonetheless managed to secure substantial V-2 technology through their occupation of eastern Germany. Soviet forces captured the Peenemünde facility, various production sites, and compelled numerous German engineers to work for Soviet programs. The Soviets were more heavy-handed than the Americans in this recruitment, often giving German engineers little choice about relocating to the Soviet Union. These German specialists worked on Soviet missile development for years before being allowed to return to Germany, by which time Soviet engineers had absorbed their knowledge and begun to develop indigenous Soviet missile technology. The competition between American and Soviet missile programs, each building on captured German V-2 technology, would drive the arms race and space race for decades. The V-2 rockets that had terrorized London and Antwerp in 1944 and 1945 became the foundation for the missiles that would enable nuclear deterrence and, eventually, for the rockets that would launch satellites and astronauts into space. The V-1 flying bomb, while less technologically sophisticated than the V-2, also attracted Allied interest as an early guided weapon. British forces, who had been the primary targets of V-1 attacks, captured production facilities and studied the V-1's pulse jet engine and guidance systems. The V-1 represented a different approach to long-range attack than the ballistic V-2, and both American and British military planners saw potential in further developing cruise missile technology. Soviet forces similarly examined V-1 technology, though they focused more heavily on the ballistic missile capabilities represented by the V-2. In the years following the war, all three major Allied powers would develop their own cruise and ballistic missiles, drawing on German wartime research while adding their own innovations and improvements. The rapid advancement of missile technology in the late 1940s and 1950s can be directly traced to the capture and exploitation of German V-weapon programs. Beyond the V-1 and V-2, German rocket research had explored numerous other concepts that intrigued Allied investigators. Projects for anti-aircraft missiles, air-to-air rockets, and even proposals for intercontinental ballistic missiles were found in captured German documents. While most of these existed only as designs or prototypes, they revealed the scope of German ambitions and provided starting points for Allied research programs. The Wasserfall anti-aircraft missile, Schmetterling guided bomb, and various other guided weapons projects were examined, and in some cases influenced Allied weapons development. American guided missile programs in particular drew heavily on German research, with captured documents providing blueprints for weapons that would not enter American service for years, but whose conceptual groundwork had been laid by German engineers desperate to find a way to counter Allied air superiority. The question of what to do with captured German chemical weapons posed unique challenges given the international treaties banning their use and the horrific legacy of gas warfare in World War I. Germany had produced and stockpiled enormous quantities of chemical weapons during the war, but, unlike World War I, had not employed them on the battlefield, possibly due to fear of Allied retaliation or Hitler's personal experience of gas warfare in the First World War. When Allied forces discovered German chemical weapons stockpiles, they found not only traditional agents like mustard gas and phosgene, but also far more lethal nerve agents that German chemists had developed in the 1930s and early 1940s. Tabun, sarin, and soman, collectively known as the G-series nerve agents, represented a quantum leap in chemical weapons lethality and were completely unknown to Allied intelligence until their discovery in captured German facilities. These agents were so toxic that even minute exposures could prove fatal, and their discovery shocked Allied chemical warfare specialists, who immediately recognized their potential to revolutionize chemical warfare. The disposition of these chemical weapons stockpiles required careful consideration. The immediate priority was preventing their use by any unauthorized parties and ensuring they did not fall into the wrong hands during the chaotic post-war period. Allied forces placed guards on chemical weapons storage sites and began the painstaking process of cataloguing what had been captured. The nerve agents particularly demanded detailed study, as Allied nations had nothing comparable in their own arsenals. American and British chemical warfare units carefully sampled the nerve agents, produced small quantities for testing, and began developing defensive measures including detection methods and medical countermeasures. The Soviet Union, which captured substantial chemical weapons stockpiles in eastern Germany, conducted similar research while maintaining tight secrecy about their findings. The knowledge gained from captured German nerve agents would lead all major powers to develop their own nerve agent programs in the Cold War, though the use of such weapons remained taboo and international efforts to ban chemical weapons would eventually culminate in the Chemical Weapons Convention of 1993. The actual destruction of German chemical weapons stockpiles proceeded slowly and with great caution throughout the late 1940s and early 1950s. Many of the chemical weapons were dumped at sea, a disposal method that was considered acceptable at the time but would later be recognized as environmentally hazardous. Allied forces loaded chemical artillery shells and containers onto ships and transported them to deep ocean areas where they were dumped overboard. The Baltic Sea and the North Atlantic received thousands of tons of German chemical munitions, which slowly corroded on the seabed, their contents gradually leaking into the marine environment. Some chemical weapons were destroyed by incineration at specialized facilities, a process that required careful controls to prevent toxic releases. Other stockpiles were simply buried in remote locations, creating long-term environmental hazards that would not be fully appreciated for decades. The discovery and disposal of chemical weapons continues even today, with munitions from both world wars periodically uncovered during construction projects in Europe, requiring specialized explosive ordnance disposal teams to safely remove and destroy them. Moving to a different category entirely, the fate of Germany's advanced optical and precision instruments reveals how some German military technology found peaceful applications. German optics firms like Zeiss and Leica had produced some of the world's finest binoculars, periscopes, rangefinders, and gun sights for military use. Allied forces seized vast quantities of these precision instruments, recognizing their value both for immediate military use and for civilian applications. The quality of German optics was renowned, and captured German binoculars and rangefinders were eagerly claimed by Allied officers for their personal use or for equipping their units. Zeiss factories in particular became prizes of war, with both American and Soviet forces competing to secure the facilities and their skilled workers. The Soviets, who occupied the main Zeiss facilities in Jena, dismantled entire production lines and shipped them to the Soviet Union, while also compelling German optical workers to relocate and establish new factories in Soviet territory. This brutal but effective technology transfer enabled the Soviet Union to dramatically improve its own optical industry, which had lagged behind Western standards before the war. The American and British forces, operating in Western Germany, secured other German optical facilities and either dismantled them or placed them under Allied control. Some German optics companies were permitted to resume limited civilian production under strict licensing and supervision, their military production capabilities destroyed or removed, but their expertise preserved for economic reconstruction. The division of German optical technology between East and West created duplicate Zeiss companies, one in East Germany continuing under Soviet influence and one established in West Germany under American supervision, a situation that would persist throughout the Cold War. This splitting of German industrial capabilities between Allied occupation zones became a pattern across many industries, from chemicals to electronics, with companies that had been unified before the war finding themselves divided by the Iron Curtain. German shipbuilding technology and naval architecture also attracted significant Allied interest. Beyond the vessels themselves, the Allies were curious about the methods and techniques German shipyards had used to produce submarines, surface combatants, and auxiliary vessels under increasingly difficult conditions as Allied bombing intensified. American naval architects examined German shipyard facilities, documenting the use of prefabrication and modular construction techniques that had allowed Germany to continue building U-boats even as traditional shipyards were destroyed. British naval engineers similarly studied German welding techniques and quality control procedures, seeking insights that could improve their own shipbuilding industry. The Soviets, whose shipbuilding capacity had been devastated during the war, were particularly aggressive in seizing German shipbuilding equipment and expertise, dismantling entire shipyards in eastern Germany, and transporting the machinery to Soviet ports where it would help rebuild Soviet naval construction capabilities. The question of what to do with captured German torpedo technology illustrates another dimension of Allied interest in specific weapon systems. German torpedoes had incorporated acoustic homing guidance systems that allowed them to track Allied ships by the noise of their propellers, a capability that had proven devastatingly effective in Atlantic convoy battles. Allied forces captured numerous examples of these acoustic torpedoes and subjected them to exhaustive testing to understand their operating principles and develop countermeasures. The acoustic homing technology represented a significant advancement over traditional straight-running torpedoes, and both American and British torpedo development programs drew on captured German designs when creating their own acoustic torpedoes in the late 1940s and 1950s. The Soviets, as with so many other weapon systems, also acquired German torpedo technology and incorporated it into Soviet weapons development. German electronics and communications equipment formed yet another category of captured military technology that demanded Allied attention. German radio equipment, encryption devices, and early radar systems were seized and analysed, though in this domain, Allied technology was generally equal to or superior to German capabilities. The exception was in certain specialized areas where German engineers had pursued innovative approaches. German infrared night vision devices, for example, were more advanced than Allied equivalents, and several German Panzer tanks had been equipped with experimental infrared systems that allowed them to see and fight at night. Allied forces captured these systems and studied them carefully, recognizing that night vision technology could provide significant tactical advantages. Similarly, German work on radio-controlled weapons and early television-guided bombs interested Allied weapons developers, though practical applications of these technologies would take years to mature. The infamous Enigma encryption machines and the even more sophisticated Lorenz cipher machines that Germany had used for high-level communications were seized by Allied forces, though by 1945 both British and American cryptanalysts had already broken these systems and were reading encrypted German messages. The capture of physical Enigma machines and code books confirmed Allied understanding of the devices and provided additional keys and settings that helped fill gaps in the historical record. Some Enigma machines were retained for museum collections or intelligence use, while others were distributed to Allied nations that had not yet developed their own sophisticated encryption systems. Remarkably, the British government gave or sold Enigma machines to various Commonwealth nations and other allies in the post-war years, without informing these countries that the British could read Enigma encrypted communications, allowing British intelligence to monitor friendly nations' secure communications for years. The disposal of massive quantities of German ammunition posed significant logistical and safety challenges that continued for years after the war ended. Germany had produced billions of rounds of small arms ammunition, millions of artillery shells, and countless bombs, grenades, mines, and other explosive devices during the war. Much of this ammunition was scattered across Europe in dumps, bunkers, storage facilities, and even just stacked in open fields where retreating German forces had abandoned it. The Allies faced the daunting task of identifying, securing, and disposing of these enormous stockpiles while preventing unauthorized access and avoiding accidental detonations. The scale of the problem was almost incomprehensible, with some ammunition dumps containing thousands of tons of munitions that required careful handling to avoid catastrophic accidents. Allied forces employed various methods to dispose of German ammunition, depending on its type, condition, and location. Some ammunition in good condition was taken for Allied use or given to Allied client states that needed to equip their military forces. Polish, Yugoslav, and other Eastern European armies used vast quantities of captured German ammunition throughout the late 1940s and into the 1950s, gradually expending the stocks as they transitioned to Soviet standard weapons and ammunition. The bulk of German ammunition, however, particularly that which was damaged, deteriorated, or simply too abundant to use, was destroyed through controlled detonation or dumping at sea. Allied engineers would load German ammunition onto ships, transport it to deep ocean areas, and push it overboard, a disposal method that was considered safe and practical at the time. Millions of tons of German munitions were dumped into the North Sea, the Baltic Sea, and the Atlantic Ocean, where they would slowly corrode and occasionally pose hazards to fishing vessels and underwater construction projects decades later. Land-based destruction of ammunition involved creating controlled explosions in remote areas where the blast and fragments would not endanger civilian populations. Allied demolition teams would gather German ammunition at sites far from inhabited areas, set explosive charges, and detonate the stockpiles, creating massive explosions that could be heard for miles. This process continued for months and even years in some areas, with periodic controlled detonations eliminating German ammunition caches as they were discovered. Some ammunition dumps proved too dangerous to move and were simply destroyed in place, with entire bunkers and storage facilities demolished to ensure the contents could never be used. The environmental impact of these massive detonations and the chemical residues they released was not a primary concern in the immediate post-war period, though modern environmental standards would consider such practices unacceptable. The problem of unexploded German ordnance, bombs and shells that had been dropped or fired during the war but failed to detonate, created a long-term hazard that persists to this day. Allied bombing had dropped hundreds of thousands of bombs on German cities and industrial targets, and a small percentage of these bombs had failed to explode on impact. Similarly, artillery bombardments had left countless unexploded shells in the soil across battlefields from Normandy to the Eastern Front. German forces had also laid millions of mines to defend their positions, and many of these remained buried and dangerous long after the fighting ended. The task of clearing these hazards fell initially to military engineers and later to specialized civilian explosive ordnance disposal teams. In heavily bombed German cities like Hamburg, Berlin, and Dresden, unexploded bombs continued to be discovered during post-war reconstruction, requiring evacuation of entire neighborhoods while disposal teams worked to defuse or safely detonate the weapons. The human cost of unexploded ordnance was significant in the years following the war. Curious children exploring bombed-out buildings, farmers ploughing fields, and construction workers excavating sites all risked encountering unexploded munitions. Accidents claimed hundreds of lives in the immediate post-war years, and the danger persisted for decades. Even today, unexploded ordnance from World War II is regularly discovered in Europe, requiring the evacuation of civilians and the deployment of bomb disposal experts. In Germany alone, several thousand tons of unexploded bombs and shells are discovered and safely disposed of each year, a grim reminder of the war that ended more than 75 years ago. The economic cost of this ongoing disposal work runs into millions of euros annually, a lasting burden of the conflict. The specialized category of German flamethrowers and incendiary weapons received limited Allied attention compared to more sophisticated systems. Flamethrowers had been used by German assault troops for bunker clearing and defensive operations, but by 1945 they were viewed as crude and inhumane weapons with limited tactical value. Allied forces captured stockpiles of German flamethrowers, but generally destroyed them rather than studying or retaining them. The psychological impact of flamethrowers had always exceeded their practical military effectiveness, and all major armies were moving away from their use even before the war ended. Incendiary ammunition and grenades were similarly destroyed in bulk, with only small samples retained for reference purposes. German armoured vehicles beyond main battle tanks constituted a diverse category that included assault guns, tank destroyers, armoured personnel carriers, and various specialised vehicles. The assault guns, particularly the Sturmgeschütz III and IV, had been produced in enormous numbers during the war and served as effective infantry support weapons and tank destroyers. When the war ended, thousands of these vehicles were scattered across Europe in various states of repair. The Sturmgeschütz III, which had been Germany's most produced armoured fighting vehicle with over 10,000 built, attracted Soviet interest as a proven and relatively simple design. Soviet forces captured hundreds of assault guns and incorporated some into their own armoured units, while using others for training purposes. Many Sturmgeschütz variants ended up in the armies of Eastern European nations, where they served alongside captured German tanks throughout the late 1940s. Romania, Bulgaria, and Syria all operated captured German assault guns for years after the war, some remaining in service well into the 1950s. The Jagdpanzer tank destroyers, including variants like the Jagdpanther and Jagdtiger, represented Germany's late war philosophy of mounting powerful guns on armoured chassis without turrets, creating vehicles that were cheaper and faster to produce than conventional tanks. Allied forces found these tank destroyers formidable on the battlefield and interesting from a technical standpoint, though their lack of turrets limited their tactical flexibility. American and British engineers examined captured Jagdpanzers, documenting their advantages and disadvantages for future reference. The massive Jagdtiger, mounting a 128mm gun and weighing 70 tons, was particularly noteworthy as one of the heaviest armoured vehicles of the war. Only about 70 Jagdtigers were produced before the war ended, and most were destroyed in combat or abandoned by their crews. The few that survived into Allied hands were studied and then scrapped, their enormous size and mechanical complexity making them impractical for any post-war use. German half-tracks, the Stückakev Z series of armoured personnel carriers and support vehicles, had motorised German infantry and provided mobility to artillery and anti-aircraft units throughout the war. These vehicles combined wheeled front axles with tracked rear drives, offering better cross-country performance than trucks while being simpler and cheaper than fully tracked vehicles. Allied forces captured thousands of German half-tracks and found numerous uses for them during the occupation period. American forces in particular appreciated the utility of half-tracks for transportation and security duties in occupied Germany, and some captured German half-tracks were pressed into service alongside American vehicles. The Soviets similarly used captured half-tracks, though they generally preferred fully tracked designs for their own forces. Most German half-tracks that were not immediately useful were scrapped, their aluminum and steel components recycled for reconstruction purposes. Moving to another category entirely, the fate of German naval mines and torpedoes created ongoing hazards that required years of dangerous work to address. Germany had laid hundreds of thousands of naval mines in coastal waters, shipping lanes, and harbour approaches throughout the war. These mines, which detonated when struck by ships or triggered by magnetic or acoustic sensors, remained active long after hostilities ceased and posed serious threats to maritime traffic. Allied navies organised extensive minesweeping operations that lasted into the early 1950s. Slowly clearing shipping lanes and coastal areas of German mines, the work was tedious and dangerous, with minesweeping vessels methodically dragging sweep gear through suspected minefields to detonate or dislodge mines. Casualties among minesweeping crews were not uncommon, as mines sometimes detonated unexpectedly or sweep gear malfunctioned. Some German naval mines are still occasionally discovered today, requiring specialized explosive ordnance disposal teams to render them safe or conduct controlled detonations. German torpedoes found in storage or aboard captured vessels were generally destroyed unless they incorporated technologies of interest like acoustic homing systems. Thousands of torpedoes were dumped at sea along with other unwanted munitions, while others were disassembled to recover their explosive charges for safe disposal. The complexity and danger of handling torpedoes, which contained hundreds of pounds of high explosives and sophisticated mechanisms, meant that caution was paramount. Allied naval ordnance personnel developed procedures for safely rendering German torpedoes inert, but accidents did occur when old or corroded weapons behaved unpredictably. The question of what happened to Germany's nuclear weapons research materials and facilities represents one of the most dramatic episodes in the seizure of German military technology, though Germany never came close to building an actual atomic bomb. The German nuclear program, led by physicist Werner Heisenberg, had explored uranium enrichment and reactor design, but had made far less progress than the Allied Manhattan Project. When American and British forces advanced into Germany in early 1945, special intelligence teams known as Alsos units raced to capture German nuclear facilities, scientists and materials before the Soviets could reach them. The primary concern was not that Germany had a functional nuclear weapon, but that German nuclear knowledge might fall into Soviet hands and accelerate Soviet atomic bomb development. The Alsos team successfully captured key German nuclear research sites, including the experimental reactor facility at Haigerloch and the uranium processing plant at Oranienburg. American forces seized approximately 10 tons of uranium ore and hundreds of kilograms of processed uranium metal, removing it from Germany to prevent any possibility of its use in weapons programs. German nuclear scientists, including Heisenberg, Otto Hahn, and several others were detained and held at Farm Hall, a facility near Cambridge, England, where British intelligence secretly recorded their conversations to assess their knowledge and reactions to the American atomic bombings of Japan. These Farm Hall transcripts revealed that German scientists had significantly underestimated the scale of effort required to build an atomic bomb and had pursued technical approaches that would not have succeeded even with unlimited resources. The German heavy water production facility at Vemork in Norway, which had been repeatedly attacked by Allied commandos and bombers during the war, was thoroughly examined and secured after the German surrender. Heavy water, which the Germans had intended to use as a neutron moderator in experimental reactors, had been produced in limited quantities before Allied actions disrupted production. The remaining stocks of heavy water were seized and the production equipment was dismantled to ensure it could not be used in future weapons programs. Soviet forces, arriving later at some German nuclear sites, found them already stripped of the most valuable materials and scientists, a source of significant frustration for Soviet intelligence, which correctly recognized the strategic importance of atomic energy. The division of German nuclear expertise between Western allies and the Soviet Union played a role in the subsequent nuclear arms race, though the impact of captured German knowledge was far less significant than sometimes portrayed in popular accounts. German rocket and jet engine technology beyond the famous V-2 and Me-262 encompassed a wide range of experimental and developmental projects that revealed the breadth of German aerospace research. Allied intelligence teams discovered wind tunnel data, aerodynamic studies, and design proposals for aircraft and missiles that were years ahead of Allied equivalents. Swept-wing research in particular proved invaluable to post-war aircraft design, as German engineers had systematically studied the benefits of sweeping wings backward to delay the onset of compressibility effects at high subsonic and transonic speeds. This research, captured in documents and embodied in aircraft like the Messerschmitt P-1 experimental fighter, accelerated American and Soviet development of swept-wing jets. The North American F-86 Sabre, which would become famous in the Korean War, directly benefited from captured German swept-wing research, as did the Soviet MiG-15. German research into ramjet and scramjet propulsion, though not developed into operational weapons, during the war provided Allied engineers with starting points for their own hypersonic vehicle research. The Germans had also explored various exotic propulsion concepts, including pulse jet engines more advanced than the simple unit used in the V1, rocket motors with throttling capability, and even early designs for turbofan engines that would become standard in civilian and military aviation decades later. The documentation of these research programs filled entire warehouses with technical drawings, test reports, and theoretical studies. American, British, and Soviet technical intelligence teams spent months and even years sorting through this material, translating German documents, and extracting useful information. German radar and electronic warfare research had produced a variety of systems for air defense, navigation, and offensive operations. German scientists had developed airborne radar sets for night fighters that allowed Luftwaffe pilots to hunt Allied bombers in darkness, radar altimeters for precise low-level flying, and various electronic countermeasures devices designed to jam or deceive Allied radars. While Allied radar technology was generally superior by 1945, German approaches to certain problems offered alternative solutions that complemented Allied knowledge. British and American electronics engineers carefully examined German radar equipment, paying particular attention to components and techniques that might be adapted for Allied use. Soviet forces seized German radar manufacturing facilities and technical documentation, using the captured knowledge to improve Soviet radar capabilities, which had lagged significantly behind Western standards during the war. The German glide bomb program, which had developed weapons like the Fritz X and Henschel HS-293, represented early progress toward precision-guided munitions. These weapons, controlled by radio links from the launching aircraft, had been used with some success against Allied ships in the Mediterranean. Allied forces examined captured glide bombs and the control systems that guided them, recognizing that the concept of standoff precision attack offered significant tactical advantages. While the German implementations had reliability problems and were vulnerable to electronic jamming, the basic concept of guiding a bomb or missile to its target would become fundamental to post-war weapons development. American smart bomb programs in particular drew lessons from German glide bomb experience, though many years would pass before truly effective precision-guided munitions entered service. The vast array of German military vehicles beyond armoured fighting vehicles included trucks, motorcycles, staff cars, and various specialised vehicles that had kept the Wehrmacht mobile, despite chronic fuel shortages and Allied air attacks. Allied forces found thousands of German vehicles in varying conditions, from pristine staff cars to burned-out wrecks. The utility vehicles were often pressed into service by Allied occupation forces, as there was always a need for transportation, and many German vehicles were well engineered and reliable. American forces drove captured German trucks, jeeps, and cars throughout the occupation zone, while Soviet forces similarly used German vehicles to supplement their own motor pools. The famous Volkswagen Kübelwagen, Germany's equivalent to the American Jeep, proved popular with Allied soldiers who appreciated its air-cooled engine and rugged construction. British forces actually placed orders for new production of the Volkswagen Type 1 civilian car, the Beetle, from the Volkswagen factory in Wolfsburg, recognizing the vehicle's quality and the factory's potential to support occupation logistics while providing employment for German workers. German military motorcycles, particularly those produced by BMW and Zundap, were high-quality machines that Allied soldiers often acquired for personal use. The BMW R75 and Zundap KS 750 heavy motorcycles with sidecars had served German forces on all fronts and were known for their reliability and off-road capability. Many of these motorcycles survived the war intact and found their way into Allied hands, either through official captures or individual acquisition by soldiers. Some were shipped home by Allied veterans, while others remained in Europe and eventually entered the civilian market as surplus military equipment was sold off in the late 1940s and 1950s. German staff cars, including Mercedes-Benz and Horch luxury vehicles that had been used by senior officers, became prized possessions of Allied commanders during the occupation. General Eisenhower and other senior Allied leaders drove captured German staff cars, appreciating their comfort and engineering quality. The question of what to do with Germany's military infrastructure, the fortifications, bunkers and defensive works that had been constructed throughout occupied Europe and Germany itself posed challenges that persisted for decades. The Atlantic Wall, Hitler's massive system of coastal fortifications stretching from Norway to the French-Spanish border, consisted of thousands of concrete bunkers, gun emplacements, and obstacles. After the war, these structures served no military purpose for the Allies and were too massive to easily demolish. Some fortifications were destroyed by explosives, particularly those that obstructed port operations or blocked desirable real estate, but most were simply abandoned and left to decay. Today, Atlantic Wall bunkers dot the European coastline as historical monuments and tourist attractions, their thick concrete walls slowly crumbling but still standing as monuments to German engineering and the futility of static defence against determined attackers. The West Wall, or Siegfried Line, the system of fortifications along Germany's western border, similarly remained largely intact after the war. Allied forces had breached the West Wall during their invasion of Germany in 1944 and 1945, and after the surrender there was little point in further demolishing the structures. Some bunkers were used by Allied occupation forces for storage or as administrative spaces, while others were simply sealed and forgotten. In eastern Germany, fortifications along the old German-Polish border were sometimes reused by Soviet or Polish forces, but many were abandoned as military thinking shifted away from static defence and toward mobile warfare. The massive flak towers constructed in German cities like Berlin, Hamburg, and Vienna proved almost impossible to demolish due to their thick concrete construction, and several remain standing today, converted to peacetime uses or left as indestructible monuments to the war. German military communications infrastructure, including telephone networks, radio stations, and command bunkers, was seized by Allied forces and often pressed into service for occupation administration. The extensive network of military telephone lines and exchanges that Germany had built was valuable for Allied military governments trying to establish control over occupied territory. Allied signals units took over German communication centres, modified them for Allied use, and operated them throughout the occupation period. German military radio equipment was similarly evaluated and sometimes used, though Allied forces generally preferred their own proven equipment for critical communications. The elaborate command bunkers from which German military leaders had directed operations, including the Reich Chancellery bunker, where Hitler spent his final days, were thoroughly searched for intelligence materials and then either demolished or sealed. The fate of German military uniforms and personal equipment represents a more mundane but still significant aspect of captured material. Millions of German uniforms, boots, helmets, and personal gear items were in Allied hands by the war's end. Some items were kept as war souvenirs by individual soldiers, while others were issued to displaced persons or refugees who needed clothing. Large quantities of German uniforms and equipment were simply destroyed by burning or burial, as they had little practical value, and storing them would have been impractical. German helmets, the distinctive Stahlhelm design, became popular souvenirs among Allied troops, and many were brought home as keepsakes. Today, these helmets are common items in military antique collections, testament to both their iconic design and the sheer numbers produced during the war. German military medical equipment and supplies faced distribution based on immediate humanitarian needs. Allied forces discovered extensive stocks of German medical supplies in military hospitals and depots, and these were often redistributed to civilian hospitals and clinics that were desperately short of basic medical materials. German pharmaceutical products, surgical instruments, and medical devices were evaluated for quality and safety before being issued to medical facilities in occupied Germany. The German medical industry had produced high-quality instruments and medications, and much of this material proved valuable for treating both German civilians and Allied personnel during the occupation period. Some captured German medical innovations, particularly in the field of trauma surgery and orthopedics, influenced Allied medical practice as doctors learned from German techniques developed under the brutal conditions of the Eastern Front. The specialized category of German reconnaissance and intelligence equipment revealed the extent of German efforts to gather information about Allied forces and intentions. Cameras for aerial reconnaissance, signal intelligence equipment for intercepting Allied communications, and various espionage devices were captured and examined. German aerial reconnaissance cameras had been among the finest in the world, with Zeiss and other manufacturers producing high-resolution cameras capable of photographing targets from great altitudes. Allied intelligence services studied these cameras and their associated equipment, noting design features and optical quality that matched or exceeded Allied equivalents. Some of this equipment was retained for Allied use, while other examples went to technical intelligence facilities for detailed analysis. German signals intelligence equipment, including radio intercept receivers and direction-finding systems, was similarly examined to understand German capabilities and to identify any technical innovations that might be adopted for Allied use. German cryptographic materials beyond the Enigma machines included various one-time pad systems, code books, and documents that provided insights into German communications security practices. Allied signals intelligence services methodically catalogued these materials, using them to reconstruct German communications networks and understand how German forces had organized their command and control systems. The bureaucratic records of German signal intelligence units were particularly valuable, revealing which Allied codes and ciphers the Germans had successfully broken and which had remained secure. This information helped Allied cryptographers assess the security of their own systems and make improvements where vulnerabilities had been identified. The irony was not lost on Allied intelligence officers that they were learning about the security of Allied communications from captured enemy documents rather than from their own security assessments. The mundane but essential category of German military rations and food supplies had to be addressed as part of the overall task of managing captured material. German forces had stockpiled considerable quantities of rations, though the quality and variety had declined sharply in the final years of the war due to Allied bombing and shortages of raw materials. Allied occupation authorities took control of these food stocks and generally distributed them to displaced persons, concentration camp survivors, and German civilians facing severe food shortages in the immediate post-war period. The German military had produced various types of preserved foods, including canned meats, hardtack biscuits, and dehydrated soups, and while these were not appetizing, they represented calories that could help prevent starvation during the chaotic months following the surrender. Some Allied soldiers acquired German rations out of curiosity or necessity, sampling the unfamiliar foods and generally concluding that German rations were comparable in quality to Allied equivalents, neither particularly good nor terrible, but adequate for sustaining soldiers in the field. German camouflage and concealment technology represented another area where Allied forces found innovations worth studying. German forces had made extensive use of camouflage patterns on uniforms, vehicles, and equipment, developing distinctive patterns like the various camouflage smocks worn by Waffen-SS troops and the ambush patterns painted on armoured vehicles. Allied camouflage experts examined German approaches to concealment, noting the effectiveness of certain patterns and techniques. The German use of wire mesh frames covered with vegetation to conceal vehicles and positions impressed Allied observers as simple but effective, and similar techniques were adopted by Allied forces. German development of infrared-absorbing paints and materials designed to reduce visibility to infrared detection systems represented early work in stealth technology, and while practical applications were limited during World War II, the concepts would later prove important in Cold War military development. The extensive network of German military warehouses, depots, and supply centers contained an almost bewildering variety of equipment and supplies when Allied forces took control. Inventories of captured German military property filled thousands of pages as occupation authorities attempted to catalogue what they had seized. The variety was staggering, from spare parts for weapons and vehicles to office supplies, from musical instruments for military bands to leather working tools for saddle and boot repair. German military organization had been thorough in equipping its forces with everything deemed necessary for operations, and the accumulated material from 6 years of war represented an enormous asset if it could be properly managed and utilized. Allied military government officials faced the challenge of sorting through this mountain of material, identifying items of value, and disposing of the rest in an orderly manner. The specialized equipment used by German mountain troops and other specialized units added to the variety of captured material. Mountain warfare equipment, including skis, climbing gear, cold weather clothing, and specialized weapons, adapted for alpine conditions, were examined by Allied mountain warfare specialists. Some of this equipment was quite sophisticated, reflecting years of German experience in mountain operations from Norway to the Caucasus. Allied forces serving in mountainous regions during the occupation period sometimes used captured German mountain warfare equipment, finding it well designed for its intended purpose. The specialized boots, clothing, and gear developed for German mountain troops influenced post-war Allied mountain warfare equipment development, with various design features and materials choices being adopted by American and British forces. German military musical instruments, from trumpets and drums to harmonicas and accordions, represented a category that might seem trivial but actually reflected important aspects of military life and morale. German military bands had used high-quality instruments, often manufactured by renowned German musical instrument makers. Some of these instruments were taken by Allied soldiers as souvenirs or for personal use, while others were donated to civilian musical groups or schools in Germany and Allied nations. The symbolic value of former military musical instruments being used for peaceful civilian music making appealed to many people in the post-war years, representing the transformation of military power into cultural activity. Some German military trumpets and other brass instruments made their way into jazz bands and orchestras, their origins gradually forgotten as they became simply musical instruments rather than military equipment. The question of what happened to German military training equipment and facilities reveals another dimension of Allied occupation policy. Germany had developed extensive training facilities for its military forces, including firing ranges, tank training grounds, armor schools, flight training facilities, and various specialized schools for different military occupations. Allied forces took control of these facilities and in many cases converted them for Allied use. The extensive tank training grounds at Bergen-Hohne in northern Germany, for example, were taken over by British forces and continue to be used by NATO forces today. Flight training facilities were similarly converted to Allied use, with former Luftwaffe airfields becoming bases for American, British and French air forces during the occupation period. The specialized equipment at these facilities, including training aids, simulators and instructional materials, was examined for any useful innovations before being destroyed or adapted for Allied training purposes. German military publications, including training manuals, technical documents, field regulations, and doctrinal studies, were seized in enormous quantities and provided valuable insights into German military thinking and organization. Allied intelligence services and military education institutions carefully studied these documents, translating the most important texts and distributing them for analysis. German tactical doctrine, particularly the emphasis on initiative, combined arms operations, and the use of mission-type orders rather than detailed commands, had proven highly effective on the battlefield, and Allied military theorists studied German approaches carefully. Some German training manuals and technical documents were distributed to Allied military schools, where they influenced post-war military education. The German emphasis on practical training and realistic exercises impressed Allied observers and contributed to reforms in Allied military training systems. The specialized tools and equipment used by German military engineers represented another substantial category of captured material. German pioneer units had been equipped with an array of specialized tools for construction, demolition, and obstacle creation and removal. These included bridge-building equipment, mine detectors, demolition charges, earth moving tools, and various specialized devices for military engineering tasks. Allied engineer units examined German equipment, noting innovations and effective designs that might be adopted or adapted for Allied use. Some German engineer equipment was pressed into service by Allied occupation forces for reconstruction work, while other items were retained for study or distributed to Allied engineer schools for training purposes. The quality of German engineering tools was generally high, reflecting Germany's strong tradition of precision manufacturing and tool making. The capture of German naval mining equipment and mine warfare technology provided Allied navies with detailed knowledge of German mine designs and laying techniques. German magnetic and acoustic mines had posed serious threats to Allied shipping throughout the war, and understanding their operating principles was essential for developing effective countermeasures and mine detection systems. Allied naval mine warfare. Specialists carefully studied captured German mines, documenting their trigger mechanisms, explosive charges, and deployment methods. This knowledge contributed to improved Allied mine warfare capabilities in the Cold War period, when mine warfare remained an important naval consideration. The Germans had also developed various types of mine-laying equipment, including specially modified submarines for covert mining operations, and Allied navies examined these systems to understand German capabilities and tactics. German military aviation support equipment, including ground power units, fuel trucks, bomb trolleys, aircraft towing vehicles, and maintenance equipment, was captured in enormous quantities at Luftwaffe airfields across Germany and occupied Europe. Much of this equipment was in poor condition after years of use and Allied bombing, but some examples were still serviceable and useful. Allied air forces used captured German aviation support equipment during the occupation period, particularly when Allied equipment was in short supply, or when German equipment offered specific capabilities that Allied equivalents lacked. The extensive ground infrastructure required to support German air operations, including hardened aircraft shelters, underground maintenance facilities, and dispersed storage areas, impressed Allied Air Force planners who recognized the value of protecting aircraft and support facilities from air attack. These lessons influenced Cold War air-base design, with facilities increasingly hardened and dispersed to reduce vulnerability. German night fighting equipment and technology represented a specialized domain where German innovations had significant impact. The Luftwaffe had developed sophisticated systems for intercepting Allied night bombers, including airborne radar sets, ground-controlled interception systems, and various visual aids for night operations. The equipment used by German night fighter crews, including specialized gun sights, radar displays, and communications equipment, was carefully examined by Allied forces who had themselves developed considerable night fighting capabilities during the war. British night fighter forces in particular were interested in German approaches to the problem of finding and destroying bombers in darkness, and technical intelligence teams thoroughly documented German systems for comparison with British equivalents. The Germans had also experimented with infrared searchlights and detection systems for ground-based night fighting, and while these systems had limited effectiveness, they represented innovative approaches to the challenge of night combat that interested Allied researchers. The extensive German program for developing unmanned aerial vehicles and remotely controlled weapons beyond the V-1 included various experimental systems that foreshadowed modern drone technology. German engineers had developed radio-controlled bombs and missiles, explored the use of television, cameras for remote guidance, and even tested drone aircraft for reconnaissance and attack missions. These programs were generally in early developmental stages when the war ended, but the concepts and technical approaches attracted intense Allied interest. American and British researchers examined captured German remote control equipment and documentation, recognizing that remotely controlled and autonomous weapons would likely play significant roles in future conflicts. Soviet forces similarly seized German research materials related to unmanned systems, incorporating the knowledge into their own weapons development programs. The influence of German remote control technology can be traced through post-war American and Soviet weapons programs, though significant additional development was required before practical systems emerged. German protective equipment, including gas masks, chemical protective clothing, and various types of body armor, provided insights into German expectations about the nature of modern warfare. Despite possessing deadly nerve agents, Germany had not used chemical weapons on the battlefield, but German forces had been thoroughly equipped with protective equipment against the possibility of Allied chemical attacks. Allied forces captured millions of German gas masks and large quantities of chemical protective clothing, much of which was destroyed as surplus to requirements. German experiments with body armor, including steel breastplates and various types of armored vests for assault troops, demonstrated German recognition that infantry needed better protection, but also showed the limitations of available materials and designs. Allied military researchers examined German body armor developments, noting both the attempts to provide protection and the practical problems of weight and mobility that had prevented widespread adoption. The question of what happened to the enormous quantities of captured German fuel and lubricants represented a practical concern for occupation authorities. German forces had stockpiled fuel and lubricants at depots across occupied territory, and while Allied bombing had destroyed much of this material, substantial quantities remained in Allied hands after the surrender. The fuel and lubricants were generally of good quality, manufactured to German military specifications, and Allied forces used captured German petroleum products to supplement their own supplies during the occupation period. Some captured fuel was issued to German civilian authorities for essential transportation and industrial uses, helping to restart economic activity in occupied Germany. The practice of using captured enemy supplies was well established in military operations, and Allied forces saw no reason to destroy usable fuel when they could employ it for their own purposes. German military footwear and clothing technology demonstrated sophisticated understanding of the requirements for different environments and climates. German boots, uniforms, and specialized clothing for winter operations, desert conditions, and tropical climates were examined by Allied quartermasters seeking to improve their own equipment. German winter warfare clothing, developed from brutal experience on the Eastern Front, incorporated innovative designs and materials for protecting soldiers in extreme cold. Allied forces examined German fur-lined boots, padded winter uniforms, and specialized cold weather gear, noting effective features that could be adopted for Allied use. Similarly, German tropical uniforms and desert warfare clothing showed attention to ventilation, sun protection, and durability in harsh conditions. Some design elements from German military clothing found their way into post-war Allied military uniforms, though credit was rarely given to German origins. The disposal of German military vehicles that were neither useful for Allied purposes nor particularly valuable for study involved enormous scrapping operations that continued for years. Thousands of German trucks, staff cars, motorcycles, and specialized vehicles were collected at central locations where they were stripped of usable parts before being cut apart and sent to steel mills for recycling. The scale of these scrapping operations was industrial, with entire facilities dedicated to processing captured German vehicles. Workers would remove engines, transmissions, and other components that might have value either as spare parts or for civilian use, then cut apart the remaining hulks with torches. The steel recovered from scrapped German vehicles contributed to European reconstruction, literally beating swords into plowshares as military equipment was transformed into raw materials for civilian industry. German military optics beyond the famous Zeiss binoculars included a wide variety of specialized optical instruments for artillery, aviation, naval use, and infantry operations, rangefinders for artillery and naval gunnery, periscopes for armored vehicles, telescopic sights for rifles, and various other optical devices demonstrated German excellence in precision optics manufacturing. Allied forces captured these instruments in enormous quantities and found multiple uses for them. Artillery rangefinders were examined to understand German fire control methods. Rifle scopes were tested and sometimes issued to Allied snipers, and naval optical equipment was studied by Allied naval forces. The quality of German optics was consistently high, and some captured instruments remained in use for years after the war. The expertise of German optical workers was recognized as valuable, and Allied occupation authorities encouraged German optics companies to resume civilian production under strict controls, preserving important industrial capabilities while preventing military production. The fate of German military watercraft beyond the major naval vessels included thousands of small craft used for coastal defense, river operations, transport, and various specialized purposes. Motor torpedo boats, patrol craft, landing craft, ferries, and various utility vessels were distributed among Allied forces based on immediate needs and utility. Soviet forces operating in rivers and coastal waters around occupied Germany made extensive use of captured German small craft, while Western Allied forces generally had adequate numbers of their own boats and had less need for German vessels. Many German small craft were simply left to deteriorate, moored in harbours or rivers where they slowly decayed without maintenance. Some were scrapped for their metal and machinery, while others found civilian uses in the chaotic post-war years when any functional vessel had value for transportation or commerce. German military communications equipment beyond radio sets included field telephones, telephone cables, switchboards, and various signal devices that had connected German forces in the field. Allied forces examined this equipment and often used it for occupation purposes, as the extensive German military telephone network could be repurposed for Allied administrative communications. German field telephones were well-made devices, comparable in quality to Allied equivalents, and thousands were pressed into Allied service. Signal rockets, flares, and other pyrotechnic devices used by German forces for signaling and illumination were generally destroyed as too dangerous to store and unnecessary given Allied stocks of similar equipment. The destruction of these pyrotechnics provided some spectacular displays as disposal teams detonated entire stockpiles of signal flares and illumination rounds. The specialized equipment used by German parachute troops and airborne forces included parachutes, harnesses, drop containers, and various items designed specifically for airborne operations. German parachute design had followed different principles from Allied parachutes and Allied airborne. Required for military logistics were captured along with combat equipment. Allied occupation forces found immediate use for much of this equipment in supporting their own operations and beginning the massive task of reconstruction. German railway equipment was particularly valuable given the importance of rail transport in moving occupation forces and supplies. Allied military railway units operated captured German locomotives and rolling stock extensively, and some German railway equipment remained in service for decades after the war. The German system of using specialized railway equipment for military logistics, including armored trains and railway-mounted anti-aircraft guns, was thoroughly documented by Allied forces, though the era of armored trains was clearly ending with the dominance of air power. The question of what happened to the infamous symbols and regalia of Nazi military power carried both practical and symbolic weight. Nazi flags, banners, insignia, medals, and ceremonial equipment were seized by Allied forces with the dual purpose of preventing their use by Nazi sympathizers and eliminating the visual reminders of the Nazi regime. Thousands of swastika flags were burned, eagle insignia were removed from buildings and destroyed, and ceremonial equipment was either destroyed or retained as evidence for war crimes trials. Some items were kept by Allied soldiers as war trophies, a practice that occupation authorities attempted to regulate but could never completely prevent. The systematic removal of Nazi symbols from German military equipment, buildings, and public spaces was a priority for occupation authorities who recognized the power of symbols and the importance of visually demonstrating the complete defeat of Nazism. German military training films, manuals, and educational materials provided fascinating insights into how German forces had trained and indoctrinated their personnel. Allied psychological warfare specialists and military educators examined these materials, analyzing both the technical content and the propaganda elements. German military training films demonstrated various weapon systems, tactics, and procedures, and Allied forces sometimes used these films for their own training purposes after editing out the propaganda content. German tactical manuals and field regulations were carefully studied by Allied military theorists seeking to understand the principles behind German military effectiveness. The propagandistic elements of German military training, including the ideological indoctrination of troops, were examined by Allied experts studying the relationship between ideology and military performance. Understanding how the Nazi regime had molded its military forces helped Allied authorities design denazification programs and develop policies for rebuilding German society without militaristic tendencies. The specialized equipment used by German military intelligence services, including the Abwehr and other intelligence organizations, was seized by Allied counterintelligence forces. Spy equipment, including concealed cameras, invisible inks, codes, forged documents, and various espionage devices were examined to understand German intelligence capabilities and methods. Allied counterintelligence personnel studied German intelligence files and operations manuals, gaining insights into how German intelligence had operated and identifying weaknesses that Allied security services had successfully exploited. The capture of German intelligence records also exposed German agents who had operated in Allied countries, leading to arrests and prosecutions that continued for years after the war ended. Some German intelligence personnel were recruited by Allied intelligence services, their expertise in Soviet affairs and Eastern European matters proving valuable as the wartime alliance between Western Allies and the Soviet Union dissolved into Cold War confrontation. German military police, equipment and procedures were examined by Allied military police forces who needed to maintain order in occupied Germany. German military police units had used various specialized equipment, including identification document verification devices, traffic control equipment, and detention facility equipment. Allied military police sometimes used captured German equipment when it proved useful for occupation duties, though generally Allied military police forces preferred their own proven procedures and equipment. German military police records provided valuable information about German military organization and the movement of German forces during the war, helping Allied intelligence reconstruct the history of German military operations. The specialized category of German flame weapons and incendiary devices beyond standard flamethrowers included various types of incendiary grenades, firebombs, and experimental thermal weapons. German forces had used incendiary weapons for specific, tactical purposes, including clearing fortifications and destroying equipment, and Allied forces examined these weapons to understand their capabilities and limitations. Captured German incendiary devices were generally destroyed as they posed significant storage hazards and offered little that Allied forces did not already possess in their own arsenals. The use of flame weapons had always been controversial due to their horrific effects, and by 1945, military thinking was moving away from such weapons despite their tactical effectiveness in certain situations. German smoke generation equipment and obscurant devices used for concealing military operations were examined by Allied forces interested in tactical deception and concealment techniques. German forces had employed smoke extensively for covering movements, protecting positions from air attack, and masking offensive operations. Allied forces studied German smoke generators, smoke shells, and smoke grenade designs, comparing them to Allied equivalents and noting any innovations worth adopting. Some captured German smoke generation equipment was used by Allied forces during the occupation period for training and demonstrations, though most was eventually destroyed or scrapped. The question of what happened to captured German horses and other military animals represents an often overlooked aspect of seized military resources. Despite Germany's reputation for mechanized warfare, the Wehrmacht had relied heavily on horses for transportation and logistics, particularly on the Eastern Front, where fuel shortages and difficult terrain made motor transport impractical. Hundreds of thousands of horses had been used by German forces, and many of these animals ended up in Allied hands after the surrender. Allied forces used some captured German horses for their own transportation needs during the occupation, while others were distributed to German farmers who desperately needed working animals to restore agricultural production. Many German military horses were in poor condition after years of hard service and inadequate feeding, and veterinary care for these animals became a minor but necessary task for occupation authorities. The horses that survived the war and occupation period gradually returned to civilian work, their military service forgotten as they pulled ploughs and wagons in reconstructed Germany. German military working dogs, trained for guard duty, messenger services, and mine detection, faced various fates after the war. Allied forces examined German military dog training programs and sometimes retained dogs that showed useful capabilities. German shepherd dogs in particular, which had been extensively used by German military and police forces, impressed Allied handlers with their intelligence and trainability. Some German military dogs were adopted by Allied personnel and brought to Allied nations, where they became the foundation for post-war military and police dog breeding. Programs. The German emphasis on systematic dog training for military purposes influenced Allied military dog programs, with various training techniques and approaches being adopted by American, British, and Soviet forces. The disposal of German military paper records, documents, and administrative materials involved a massive sorting operation that lasted for years. German military bureaucracy had generated enormous quantities of paperwork documenting every aspect of military operations, logistics, personnel management, and administration. Allied forces seized these records and began the painstaking process of sorting through them to identify documents of intelligence value or potential use in war crimes prosecutions. Millions of pages of German military records were microfilmed or photographed to preserve the information before the originals were destroyed or stored. The captured German records would prove invaluable to historians in subsequent decades, providing detailed documentation of German military operations and enabling comprehensive study of German military organization and methods. Some records were returned to German authorities in later years, while others remained in Allied archives where they continue to be accessed by researchers today. German military construction equipment, including bulldozers, graders, pile drivers, concrete mixers, and various other engineering equipment, was valuable for reconstruction work in war-devastated Europe. Allied forces put much of this equipment to immediate use, repairing roads, rebuilding bridges, clearing rubble, and constructing new facilities. German engineering equipment was generally well made and reliable, and Allied engineers appreciated its quality even as they recognized the irony of using German equipment to repair damage that German forces had caused. Some German construction equipment remained in use for years after the war, serving civilian reconstruction projects as well as military engineering tasks. The practical value of this equipment outweighed any symbolic concerns about using German machinery. The specialized equipment used by German mountain warfare units included not just weapons adapted for alpine conditions, but also climbing equipment, specialized sleds and transport devices, avalanche protection gear, and various items designed for operating in extreme terrain. Allied mountain warfare specialists examined this equipment with interest, noting German innovations and effective designs. Some captured German mountain warfare equipment found its way to Allied mountain units, where it supplemented or replaced existing Allied gear. The Germans had gained extensive experience in mountain warfare from operations in Norway, the Alps, the Balkans, and the Caucasus, and this experience was reflected in well-designed equipment that impressed Allied evaluators. German naval officer swords, ceremonial daggers, and other symbolic weapons represented a category that had more emotional and symbolic value than practical military worth. These decorative weapons, often beautifully crafted by skilled artisans, became highly sought-after war trophies. Allied soldiers acquired German swords and daggers both through official surrender procedures and through less official means, and many of these items were brought home as souvenirs. Today, German military swords and daggers from World War II are common items in military antique collections, testimony to their appeal as symbols of a defeated enemy and examples of fine craftsmanship. The removal of these ceremonial weapons from German officers symbolized the complete dismantling of German military tradition and the humiliation of the officer corps that had led Germany into catastrophic defeat. The fate of German military flags and standards carried particular symbolic weight as these items represented unit honor and tradition in German military culture. Allied forces systematically seized German military flags, and many were burned or destroyed to prevent them from becoming rallying points for future German militarism. Some flags were retained as war trophies or placed in museums as historical artifacts. The symbolic act of capturing an enemy's flag had been significant in military tradition for centuries, and Allied soldiers who had seized German flags often treasured them as proof of their unit's combat success. The wholesale destruction of German military flags represented not just the elimination of physical objects, but the deliberate erasure of German military tradition, and the attempt to ensure that these symbols could never again inspire German military aggression. German military archive materials, including photographs, maps, and planning documents, provided valuable historical resources that were carefully preserved by Allied authorities. German military photographers had documented military operations extensively, creating a vast photographic record of the war from the German perspective. Allied forces seized these photographic archives and used them for intelligence analysis and historical documentation. German military maps, particularly those showing defensive positions, minefields, and fortifications, were essential for Allied operations and post-war reconstruction. The detailed mapping that German forces had conducted in occupied territories provided valuable geographic information that Allied forces incorporated into their own mapping programs. Planning documents and operational orders captured from German headquarters provided insights into German military decision-making and helped Allied intelligence reconstruct the history of German military operations. The question of what to do with captured German military athletic and recreational equipment reflected Allied recognition that German military forces, like all armies, had devoted resources to maintaining morale and physical fitness among troops. German military sports equipment, musical, instruments for non-band use, library books, and various recreational items were generally distributed to displaced persons camps, prisoner of war camps, or German civilian organizations. The idea that enemy equipment could serve humanitarian purposes appealed to Allied authorities who were trying to prevent starvation and maintain order in occupied Europe. German military libraries containing technical manuals and professional military literature were examined for valuable information before being distributed to appropriate institutions or destroyed. Recreational equipment was put to use in camps, housing displaced persons and refugees, providing some small comfort to people who had lost everything. German military meteorological equipment and weather forecasting facilities attracted Allied interest because accurate weather prediction had been crucial for military operations during the war. German meteorologists had established weather stations across occupied Europe and had developed sophisticated forecasting methods. Allied forces seized German meteorological instruments and records, incorporating the data into Allied weather forecasting systems. German expertise in Arctic meteorology, gained from weather stations established in remote locations like Greenland and Svalbard, proved particularly valuable. Some German meteorologists were recruited to work for Allied weather services, their knowledge of European weather patterns and forecasting techniques contributing to improved Allied weather predictions. The meteorological data collected by German forces during the war became part of the historical weather record, valuable for climate research as well as military applications. The specialized equipment used by German anti-tank units evolved considerably during the war, as German forces faced increasingly capable Allied armor. Captured German anti-tank weapons ranging from the Panzer disposable launcher to the powerful 80mm anti-tank gun were examined by Allied forces seeking to understand German approaches to the anti-tank problem. The Panzer in particular impressed Allied evaluators as a simple, effective and cheap anti-tank weapon that gave individual infantrymen the ability to destroy tanks. The design principles of the Panzer influenced post-war anti-tank weapon development in multiple nations, with weapons like the American M72 Law and Soviet RPG series drawing on concepts pioneered by the Panzer. German recoilless rifle designs were similarly influential, as these weapons offered powerful anti-tank capability without the weight and complexity of conventional anti-tank guns. The final accounting of all captured German military equipment was never truly completed, as the sheer scale and diversity of material made comprehensive cataloguing impossible. Allied forces created inventories of major weapon systems and valuable equipment, but countless smaller items were never formally recorded. The disposal process continued for years, with isolated stockpiles of German equipment being discovered and dealt with well into the 1950s. Some German military equipment found its way into museums and collections, preserved as historical artifacts or teaching tools. Other items ended up in the civilian market as military surplus, purchased by individuals and companies for various purposes. German military blankets, canteens, toolkits, and countless other utilitarian items entered civilian use, their origins gradually forgotten as they became simply useful objects rather than military equipment. The legacy of captured German weapons and technology extended far beyond the immediate post-war years. German innovations in rockets, jets, submarines, and various other fields influenced Allied military development for decades. The scientists, engineers, and technicians who had created German weapons found themselves recruited by Allied nations, their expertise valued more than their past associations. The moral complexities of employing former Nazi scientists troubled some Allied officials and citizens, but the perceived necessities of Cold War competition generally outweighed such concerns. German weapons technology, distributed among the Allied powers and studied intensively, contributed to the rapid advancement of military capabilities in the late 1940s and 1950s. The space race between the United States and Soviet Union was built on foundations laid by German rocket scientists working for their former enemies. The jet age in aviation drew heavily on German aerodynamic research and engine development. Modern submarine design still reflects innovations pioneered by German engineers in World War II. The physical destruction of German weapons represented not just practical disposal of unwanted equipment, but also symbolic closure to the Nazi regime and its military power. The sight of German tanks being scrapped, aircraft being burned, and ships being sunk demonstrated in concrete terms that Germany's capacity to wage war had been eliminated. Allied occupation authorities understood the propaganda value of these destruction operations and sometimes documented them in photographs and newsreels to reassure their populations that German military power would never again threaten peace. The weapons that had conquered much of Europe, that had killed millions of soldiers and civilians, that had represented the apex of German industrial and scientific achievement, were systematically dismantled, destroyed, or appropriated by the victors. The process was thorough, methodical, and ultimately successful in ensuring that Germany could not rearm quickly or easily. The question of whether this disposal and destruction of German weapons was entirely effective must be considered in light of subsequent history. West Germany was permitted to rearm in the 1950s as part of NATO, though under strict limitations and with former Allied enemies now serving as partners rather than occupiers. East Germany similarly created military forces under Soviet direction, though again with significant limitations compared to the Wehrmacht. The nuclear age and Cold War created a fundamentally different security environment, where the lessons of World War II's conventional warfare had to be reassessed in light of atomic weapons and ideological confrontation. The captured German weapons themselves became largely irrelevant as new technologies emerged, but the knowledge and expertise seized from Germany continued to shape military development worldwide. Well, that's it. Thanks for watching. We hope you found this video informative and gained new insights into the massive undertaking of disposing of Germany's weapons after World War II. If you enjoyed learning about today's topic, make sure to check out our video about what happened to Germany's top field marshals after the war, which explores the human side of Germany's military collapse. The fate of weapons and the fate of the people who wielded them are intertwined stories that together reveal the complete picture of how the Third Reich was dismantled. Don't forget to like this video, subscribe to our channel, and hit the notification bell to stay updated on more World War II content. We have many more fascinating stories from this pivotal period in history to explore, and your support helps us continue creating detailed, well-researched content. See you in the next one.